Good evening. Are you able to hear me? Hello? It's not coming through. Oh, uh, can you hear me? Can you hear me? What, do you have audio? Good evening. Can you hear me? I can't hear you. Can everyone hear me? Okay, very good. Okay, very good. All right, so we'll get started in about 1 minute. Um, in fact, we don't have a lot of time. It's already 7 o'clock. Geez, let me text some people really quickly and then we'll get started. So, because today is quite busy. Okay. Okay. So let me go ahead and share my screen. So today is a loaded, very busy day.
Sir? Login, bá mi sọ fún mọ́mí tó bá fẹ́ login tó David ní kó jọ yẹn sọ fún gbogbo mi náà tó bá fẹ́ login sì kẹ́ login. Ó ti bẹ̀rẹ̀.
Screen. On my screen. Okay. Can everyone see my screen? If you can see my screen, go ahead and sign in, scan the QR code, or you could also sign in by going to this website. I'll type it in the chat also so you can sign in. So let's make sure everyone is signed in, please. When you sign in, you'll get a copy of today's slides. So, and I'll put the URL again to sign in. It's to the chat. Okay, put it in the chat. So you can also click the link in the chat if you're having any difficulty with the QR code. So we'll wait for 5 minutes for everyone to sign in. Let me know if you have any issues getting the slides. Once you sign in, you should get an email with the slides. If you don't get an email with the slides, just let me know, and then I'll send you an email with the slides manually. Okay, so we'll go ahead and it's 7:05. We'll go ahead and move on. We should have more people signing in, but I'll leave the link in the chat. We'll use the link in the chat for people to sign in after the fact. So we need to move on to the quiz because there's a lot of material to do today. So okay, so go ahead and take the quiz. Scan the QR code to take the quiz. The quiz is only 15 minutes. Do the best you can. Don't stress about the quiz. It's just to give me an idea and also you an idea of where you're at and how to best make use of time, because we don't have a lot of time for these courses. We want to get everyone up to speed as quickly as possible. So it's just to give us an idea of where you're at, so we can make the best use of time on these Saturday evenings. To view the scores for the quiz, you'll log into your student portal and click on account. I'll go over at log into your student portal. We went over it on the first day. If you don't have a student portal account yet, I'll go over how to create that at the very end. Someone remind me if I don't cover that at the very end. Everyone should have a student portal account so you can view your grades. But for now, let's just go ahead and take the quiz. Again, I'll put the link for the quiz into the chat, but you should be able to scan the QR code to quickly take it so you don't have to worry about typing out or clicking on any link. Okay. The link is in the chat, so everyone should go ahead and try the quiz. Quiz is 15 minutes, so do the best you can on the quiz. It's not pass, fail, don't stress about it. We'll go over the answers to the quiz when everyone is done, but the quiz is very important to give me an idea and also you an idea of how to best make use of time. So we know what to focus on, what we shouldn't be focusing on. So just do the best you can on the quiz. So the quiz takes 15 minutes. So we'll wait for everyone to finish the quiz. You should be done by 7:20, maybe 7:25. So we'll only give people 15 minutes to take the quiz.
We can start the test now.
What was that?
We can start the quiz now.
Yes, you can start the quiz. Type your name, and then you'll be able to start the quiz. Once you type your name, the quiz will start.
Okay, all right.
Let me know if you have any difficulty accessing the quiz. I put the link to it also in the chat. If you're done with the quiz already, just put it in chat that you're done. That way we know if everyone is finished early. So we'll wait about 5 more minutes for the quiz. Okay, about 1 more minute for the quiz, 2 more minutes for the quiz. Very good. Looks like we have one, two. We have 3 more people, a couple more people working on the quiz. We'll wrap it up in about a minute, so we have time to finish.
Can submit. Can we submit? Can we submit? We can click submit.
Okay, it looks like pretty much everyone is done, so we'll go ahead and let me share my screen. Well, let me show you the quiz. So everyone can see my screen. Can everyone see my screen with the quiz? Chat. Can everyone see my screen with the, just put in the chat if you can see my screen with the quiz. Can anyone not see my screen with the quiz? Oh, am I on mute?
No, we can see it. I can see us.
You can see it?
Yeah, I can see it. Yeah.
Okay, very good, very good. Okay. So let me go ahead and so go over the quiz. So everyone should be done with the quiz. It's 15, should be 15 minutes only. I think everyone is done with the quiz. So question number 1 on the quiz, what attribute of a password affects its strength the most? Can anyone answer that?
Yeah, the length of the password.
Fantastic. Yeah, the length of the password. The longer the password is, the harder it is for someone to randomly guess it. Because obviously, the way password cracking works is it's brute force. 99% of the time, it's a brute force. So they're just guessing what is all the possible 2 characters you can use, what is all the possible 3 characters, all the possible 4 characters. They're using a very fast machine to try and guess all the possibilities. So if it's a very long password, it will take extremely long for a machine to guess what are all the possible, like 15 character combination. That's a long time. So that's why the length is so powerful. Okay. What is most, well, you have a question? Okay. So next question is, what is mostly used to identify phones in a telephone network? What is the answer to that one? Can anyone take a guess? Phone numbers. Very good. Phone numbers are used to identify phones in telephone network. So on the internet, what is mostly used to identify computers? It's IP addresses. So IP addresses play the role of a phone number for computers on the computer network or the internet. So very good. And then what is the equivalent of a phone book now on the computer network? So this is a little bit more complicated. DNS, outstanding. So DNS is playing the role of a phone book for computers. On the telephone network, you usually have like a phone book, a physical phone book that has the number and the name of a person. The DNS system associates the name of a website like google.com with an IP address. So it's playing the role of the phone book for the internet or the computer network. Very good. What does a router do on a computer network? What does a router do? Can anyone answer that? Given the options.
Yeah, it
Finds the best route.
route to other device in the network.
Very good. Excellent, excellent. So it's very intuitive. The router finds the best routes to other devices. What about a switch? What does a switch do?
I
It
didn't go.
allows
It
multiple
says it
devices.
allows multiple devices in the network
And
to share the same IP address.
very good, very good. For most networks, you don't need a switch. Like for your house, you probably don't need a switch because you only have 5 IP addresses. But imagine you're a university and the chemistry department has hundreds of machines, maybe even thousands of machines. It's going to be very, very expensive to assign each of them an IP address. That the routing for just the university would be a nightmare. So to save a lot of time and save money, oftentimes for a large organization, they'll have multiple devices share the same IP address. They use very, very big switches, not the kind that you can buy very easily. You have to be a commercial entity to usually buy these switches. They're massive switches, and they'll allow hundreds of devices to share the same IP address. So that's what a switch does. What about a modem? What does a modem do on a computer network?
Yeah, it's a converter, analog signal to digital.
Outstanding. Modem literally stands for modulator, demodulator. Modulation is the conversion of an analog signal to a digital signal. Demodulation is going backward. It's going from digital to analog. So modulation is a process of using encoding data or ones and zeros in the waves, the wave width and then the wave height of an electrical signal. So we talked about that last class and also a little bit on the first day of class. Very good. A combo box. What does a combo box do?
It combines the functions of
the
Fantastic. It combines the functions of the modem, the switch, and the router. Excellent. Now this is a little bit more difficult. Which of the following IP addresses would be assigned to a modem inside of a home or small business?
the fourth one.
What is that?
The fourth one.
The fourth one? 192.168.0.1? Very good.
Yep.
Very good. Yeah. It's inside. So 192.168, remember, is like the extension, the identifier for private IP addresses. So these IP addresses that start in 192.168 are for local machines only. They cannot be on the public internet. So very good. This is a modem inside of a home or small business. That's going to be the IP address for the assigned to the modem. Or it's going to always start with 192.168. Very good. Now, what about something that's outside? So IP address would be assigned to a database, just a database server, for example, outside of a university. I want you to focus on the word outside. Which IP address would be assigned to that?
Yeah, third one.
The third one? Very good. This is a little bit difficult because if you chose 224.54, I put that there on purpose. You should recognize that that's a multicast address. Any address that begins with 224 is multicast. It's reserved for multicasting, meaning it's reserved for video on the internet. So a device cannot be assigned that IP address because it's reserved. On the second day of class, we talked about different IP addresses are reserved for different functions on the internet. So we have experimental that begins with 240. We have multicast addresses that begin with 224. We have privates that begin with 192.168. And then basically everything else is okay. So 172 is perfectly fine. 499 is not a valid IP address. It's always between 0 and 255. The numbers are always between 0 and 255 for each octet or each block. So very good, very good. It's 172.55.217.1. Very good. Okay, so hopefully everyone did okay on the quiz. Again, I'll put your scores inside your portal. If you haven't had a chance, everyone should have a student portal account. If you don't have a student portal account, you need to go to startcanning.org. Then please go to click on the 3 lines in the top right. Wait for the website to finish loading. And then click on the 3 lines. Once it's done loading, it's taking a while to load. Yes, once it's downloaded, click on the 3 lines or the 4 lines, click on login. And then if you don't have an account, click on new user to make an account or sign up at the top. You want to make an account, your grades will be in your grade book in this portal. So make sure you sign up, make an account if you don't already have an account. Just put your information in, and then you should be able to make an account. And that's how you'll be able to see your grades in your for the quizzes. Okay.
So how can we get to that?
Oh, it's starcanyon.org. I'll put it in the chat also. Starcanyon.org. If you attended the first day, we put the it was in the slides for the first day of class, but I'll put it in here also.
Okay.
So it's in the chat. The website is starcanyon.org. You can also Google Star Canyon School, and it'll be one of the first that's on Google. So you just go to starcanyon.org, one of the first that's on Google.
Okay.
Yeah.
All right, thank you.
Very good. And you can also upload homework, upload assignments through that portal. So we'll go over how to upload assignments into the portal later on. Okay, so today we're going to continue where we finished, what we went over last time. So last time we didn't get a chance to finish part 3. Part 3 is of the introduction to computing, focusing on networks. So last time we covered part 1 and 2, or at part 1, 2, and 3, the network models, physical layer, and the network layer. We did not get a chance to talk about server types and server languages, so today we'll be talking about that. I have not had time to record the video for last time. I forgot to, click on record. In the future, if you guys notice just that the recording indicator in Zoom is not on, please feel free to just remind me anytime you see that to just quickly press record so that doesn't happen again where we go through the whole lecture and then I'm not recording. I apologize for forgetting to record that, and I haven't had time to record, to re-record it just for myself and post it in the portal for you guys, but I'll try to do that this week. Okay, so if you're old enough, you may remember that telephones used to involve something called an operator. Those of us who are above age like 30 know that back in the day, the operator of a telephone network would manually route calls. So based on certain special circumstances, a common one was long distance. So you used to have to call in order to make like a long distance call to Nigeria. You'd have to call an operator and ask them to make the long distance call. So that's how things used to, and long ago, we were talking about 30 years ago. So not very long, but in the computing time, modern computing age, 30 years is a long time. So, and in fact, there are still some businesses today that ask you to dial 0 to speak with the operator. And then the operator is an actual human being still today that connects your call for you. So operators are different from other phones on the telephone network. So on the telephone network, we have operators and then we have regular phones. And operators are different because they're not meant to really have conversation with people. So an operator is meant to be specialized to connect calls. That's the special function of an operator. You don't usually have conversations with the operator on a telephone network. So operators can also be thought of as supernodes. So on this image for this slide, you can see that there are nodes, they're little small nodes, and then there are supernodes, they are the bigger dots. So the bigger dots are the supernodes, and the small dots are the smaller regular nodes. So on any network, you have regular nodes that are small, and then you have these supernodes that are large nodes. These represent the servers, or in the case of the telephone network, the operators. So supernodes on a network are special because they are directly connected to each other. So each supernode is directly connected to another supernode. And they're also specialized for performing a service. They're not like things that you would use casually. They're highly specialized for just performing a service. So because we have supernodes or phone servers, on their phone network, and phone servers today have mostly replaced human being operators. So today we have phone servers and we don't really have human operators anymore. So when you're making a call, for example, to Ghana from Arizona, it's only going to take a few seconds instead of a few hours. And that's because once you dial the number with the country code for Ghana, the telephone protocol will send that phone signal to the nearest supernode on the telephone network. So it's not going to send it to other regular nodes on the path to Ghana. No, it's going to find the nearest supernode in Arizona or in Phoenix. And then when the signal reaches the supernode, it's going to directly jump to another supernode in Ghana. So that's the power of using these supernodes, is they are directly connected to each other. So once the signal reaches a supernode, it's able to directly jump to another supernode, usually near the destination of the signal. So the signal is encoded with the destination, and the computer network or the telephone network is able to recognize, oh, this is going to somewhere far away. Let's send it to a supernode so it can directly jump over all these small nodes and go to the nearest supernode to that actual destination. It's a very powerful method. So when the signal reaches the supernode in Arizona, again, it's going to directly jump to another supernode, say in Ghana. In reality, it might also go through supernodes in the ocean, but it's going to be a very fast trip. Once it reaches the supernode in Ghana, then it's going to send the signal along normal nodes until it reaches its final destination. So on a computer network, the server is acting like an operator. So it's fundamentally a computer, but it's not intended for use like a regular computer. It's specialized to serve only other computers, only other machines. You would not use a server, for example, to check your email. You can, though, technically. You can use a server to check your email if you want, but no one does that. A server is just a regular computer, but it's highly specialized to serve only other computers. You don't usually use it to check like email or to game. Computer servers are also supernodes, so they greatly speed up communication on the internet. So computer servers are specialized in serving certain information to other computers. One example is a DNS server. We talked a little bit about DNS last time. So DNS servers are specialized in playing the role of phone books for the internet. They store a table of domain names and IP addresses, and they basically tell you which domain name points to which IP address. That's what a DNS server does. And it's absolutely critical, because without them, you would have to like browse the internet using just IP addresses, and that'd be very difficult. Database servers are also very common, and they play the role, they're highly specialized to serve database data. So they serve database data to other machines, other computers on the internet. Web servers are very common. They are specialized in serving web information, website information. So like an HTML page. An HTML page must be understandable by a web browser to be displayed by the destination device. So that's a special situation where HTML has to be actually, the end device has to have something called a web browser to actually display the data. Without a web browser, you cannot actually read HTML. So anyway, so a web server is specially designed to serve up website data, usually HTML code. And then email servers are also very common. Email servers are specialized in sending and receiving emails on the internet. File servers are also very common. So there's different types of servers. So as you can see in this graphic for this slide, in this image, that a database server is usually directly connected to a web server, and it's sort of a backend of the web server. It's behind sort of the web server. This is because most websites have so much data that they need like a repository of the data, so that they're not, the machine, the actual web server itself is not constantly looking up or searching for data that's handled like for, Facebook or something. The searching and looking up of data is handled by a specialized server called the database server, so that process of looking up data, looking up images, looking up videos does not slow down the tasks of the web server. So there are other very important tasks of the web server, like loading the page. you don't want like the page to not load because the web server is trying to look up images. So you would, what a lot of times is done is they have a dedicated database server just for like looking up names, looking up images, so that doesn't slow down the actual loading of the website. All the important stuff is handled by the web server. Then the images, the data is handled by the database server to make things very quick. YouTube, for example, will load even if some of the images and videos are not yet loaded. So YouTube has a web server that's going to load no matter what, and then it might take a while for the actual videos to be loaded by the database behind YouTube's web server. Okay, so because of the structure shown in this graphic, people tend to call professionals that mostly work with web servers, they call them front-end developers. As you can sort of see, they're working on the front end of things, while people who mostly work with databases, they're called back-end developers. So you can see why, because the database is sort of behind the web server and functionality. So similarly, languages that are mostly used by web servers are called server-side languages because they're mostly used by the web server, or they're also called front-end languages. And then languages that are mostly used by a database, they're often called back-end languages. So the fastest servers on the internet, just to let you know, servers are really trying to speed up things. Like I said in the beginning, they're trying to speed up communication on the internet. The fastest servers on the internet tend to be operated by Amazon, just to let you know. They're part of AWS or Amazon Web Services. Google servers are probably the second fastest. But just in general, just so you know, the fastest servers operating on the internet right now are owned by Amazon. So if you're building a website and you use an Amazon server, it's probably going to be the fastest server you can get. Okay, so servers with a certain specialty will often communicate with a special protocol or with a special language. HTML is a great example of this. HTML stands for Hypertext Markup Language, and it's used by web servers to describe web pages. The HTML code is interpreted by special software called a web browser. We take for granted, everyone has a web browser. It's special software just for the purpose of interpreting HTML code. Because HTML has changed over time, over the years, it's very important to have an up-to-date browser in order to accurately display web pages. So if your browser is out of date, you might not be able to display certain web pages. A common example of that is email. Now, Google Gmail uses HTML5. So if you have a web browser that's like Internet Explorer 3 or some old web browser, you won't be able to really read email that's made by Gmail today. So it's very important to have an up-to-date web browser. That's how your machine, your device, actually reads HTML code. Web servers are also use a language called CSS. CSS describes the colors and sophisticated graphics of a web page. CSS stands for Cascading Style Sheets. And it's also improved greatly over the years. There's different types of languages now that do that. SCSS is a language that is used oftentimes in place of CSS. LESS is also a different language that does the same thing. So since web browsers ultimately display web pages, it's usually very sufficient to just ensure that the web browser is up to date. You don't really have to update the web server. As long as your web browser is up to date, the web server will serve up the HTML code. If it's advanced, then your web browser will be able to handle it as long as your web browser is up to date. So the browser is the most important thing when we're dealing with HTML. So HTTP is a special protocol used by web servers to send web pages. HTTP stands for Hypertext Transfer Protocol. I'm sure you guys have heard that before. There's also a secure counterpart called HTTPS. HTTP is basically the mechanism that's used to send the HTML code. So you have HTML, that's the actual code, and then you have HTTP, that's the mechanism used to actually send and display the HTML code. So a web browser, again, is required for understanding the protocol HTTP. So for example, when you go to google.com, you type the address google.com into a web browser, and then you hit enter or go, the browser will send an HTTP request, an HTTP protocol request to the address that you entered. Then, of course, the nearest DNS server is going to change it to an IP address. It's going to change google.com to the IP address. Then the final end machine will receive the HTTP response. And if it's a web server, if there's a web server on that machine, it's going to actually respond to the request. If the machine does not have a web server, then it will ignore the request. So you can make any machine, any device can become a web server by just installing software. You can install special software that converts the machine into a web server, or that allows it to function as a web server and understand web protocols. All of this is handled in what's called the application layer of the TCP/IP model. We talked about that last time. The application layer is what deals with web servers, web browsers, and certain software will use a certain port in order to assign the IP, the website. So we won't talk about ports, but that's all dealt with by the application layer. We won't spend too much time talking about ports. It's just best for you to understand that a dedicated machine running a web browser in software is usually used for web traffic. If you try to use like your laptop would easily get overwhelmed by the traffic, by website traffic. Unless it's a very small like website for a small business, then your laptop might actually be able to be perfectly fine web server. But for a website, most websites like TikTok, for example, a laptop would get easily overwhelmed by the traffic from TikTok. So that's why you need a dedicated machine for running a web browser. Unless it's a very small website that's not getting a lot of traffic, then you can use a small machine like a laptop. Most cases, though, you need a dedicated machine for a web server because the traffic is so heavy. So again, the network card inside of a computer is what's actually checking for the port. We won't talk again too much about that. And it's actually making sure the web device has the device has a web server on it. So the network card is what's checking if the device has a web server on it, and it's assigning HTML or HTTP protocol to a certain port. You don't need to know all that, but we'll just for future reference. And also, the port used by HTTP is 80. The port used by HTTPS is port 443. All right. So the most common languages used by web servers are HTML, CSS, JavaScript, PHP, C++, Python, Java, and MySQL. There are a lot of other languages, but we'll focus on these languages that are most common used by web servers. HTML by far is the most common, and HTML is referred to as a markup language because it is really only intended to be used by web browsers. So it's almost never used outside of a web browser. So you wouldn't really look at HTML unless you're not you're a web browser. So of those big three, HTML and CSS and JavaScript, or of those languages, the big three are HTML, CSS, and JavaScript for web servers. Only JavaScript allows you to communicate directly with the database of those big three. So to use JavaScript for a database, you need to have special software called Node.js installed on the server. And then PHP is another language that lets you communicate directly with the database. PHP is an older language, and it's used primarily by WordPress websites today. We'll talk about WordPress later on. Facebook was also initially written in PHP, and then Facebook transitioned to C++. C++ is probably the fastest. It used to be the fastest language used by web servers for a long time. Now, Go or Golang by Google is set to be a faster language, or just as fast as C++. And then MySQL is a database language, and it stands for My Structured Query Language. So we'll discuss database languages later on. Okay, very good. So now we'll get into HTML. We have 7 minutes, so I want to go a little bit quickly. So we don't usually think about it every day, but every time we read the English language, we're actually reading a form of code. In the English language, we use a special symbol called a capital letter to define the beginning of a statement. And then we use a special symbol called a period to define the end of a statement. So in English, statements are called sentences, and they begin with a capital letter, a special symbol called a capital letter, and then they end with a special symbol called a period. And a paragraph in English consists of usually like 5 sentences. So in HTML, we also have these special, sort of special symbols. But in HTML, we use more sophisticated symbols to define the beginning of a statement. These are called opening tags. So in HTML, the language is structured into tags and elements. The opening tags are 2 symbols that are like an opening bracket and a closed bracket. So you can see that in the image here on this slide. So in HTML, the symbols used to define the end of a statement are called closing tags, and closing tags are basically the same. They look the same as opening tags, but they have a slash in the middle. They have like a slash in between. So the tag type in HTML is also called the element. And the tag type, the element, is usually in between the brackets. So for example, an H1 type is also called an H1 element, and it stands for header 1, header level 1 element. So there are many types of elements in HTML. We're just going to cover the most common ones. In your book, whenever you signed up for the class, you should have received a book by John Duckett. That book is absolutely outstanding. On pages 20 to 24 in the book, he has an excellent explanation of tags and elements in HTML. So if you get a chance to read pages 20 to 24, you'll have a very good understanding of how tags, opening tags and closing tags and elements work in HTML. So again, in HTML, we'll talk about the most common HTML elements. The most common elements are H elements for headings. Also, P elements for paragraphs are very common. BR elements are for line breaks. So anytime you need to break a line, it's going to be a BR element. And A elements, literally the letter A, is for links. So it's not as intuitive. A elements, for some reason, is for links. I don't know why it's not like LIN or something, but it's A for links. And then for HTML, IMG elements are for images. And then there are other types we just focus on. There's the div elements. DIV is for division or divider. That's also very common in HTML. So we can quickly see what elements are used on a web page by right-clicking on that in any part of the page and then choosing inspect from the menu option. So we'll go ahead and quickly do that. For this, I think it's best for you guys to use Google Chrome or Firefox. Inspecting a web page using Safari is a little bit difficult because the menus are different in Safari. So now let's just go ahead and do that. Let me just demonstrate. So here's a web page. If you want to inspect any part of this web page, for example, the welcome symbol, you just right-click on it. Oh, I can't. Oh, so I disabled that for this web page anyway. So I'll go to the classes page. Some web pages it's disabled. For example, I disabled that feature on the homepage of our website. But on this page, it's not disabled, so we can try it. So if I right-click, you'll see that menu. And then if I select inspect, you'll see a little panel opens up on the right side. And you can see the elements of this web page. So you can see that this is a body element. This is a body element. And let me make it a little bit easier to read. So you can go ahead and test this on your own device, on your own laptop. So just right-click on any element, right-click on it, and then select inspect. And then you should see all of these tags. You can see this document has a lot of different elements. You can see the HTML element here. You can see a head element. You can see there's a lot of elements. So everything that has an opening bracket and a closing bracket is an HTML element. You can see the title element here, Star Canyon School of Nursing, and that's enclosed. That's surrounded by a title element with the opening and closing bracket, and also it's by the closing tag with the slash in there. So you can just quickly see what this looks like in practice by right-clicking on any part of a web page and then going to inspect, and you'll see all the tags, all the elements that comprise that web page. So you have an idea of what it looks like. Okay, we'll watch a series of videos now on how to get started writing HTML. We're gonna watch video number 1. Let me know if it plays for you guys. let me make sure that this is set up for streaming. Can everyone
Yo people, my name's Sean from the Net Ninja.
Can everyone hear the audio? So can everyone hear the audio? Okay, very good. Okay, so I'll play the video.
And I want to welcome you to your very first HTML Basics lesson. Well, I say lesson, really it's just an introduction. In this video I want to give you a brief overview of everything that we're going to be covering in this course. But before we do that, it's time to talk about prerequisites. This is everything you need to know already before you start this course. And there it is, absolutely nothing. You need to know nothing at all to start this course. Saying that, it would be useful if you can turn a computer on, navigate to a website and download some software. But apart from that, you need to know nothing about web design, HTML or programming in general. This is a beginner's course, so we're going to start from the very beginning. So, what will we be covering? Well, we'll start with taking a look at what HTML is, and by this I don't mean reading about the history of HTML, I mean looking at where it is now and how we use it with other web technologies to create websites. Then we'll look at the structure of a HTML document and download some software to create documents ourselves. I'll show you how to create a web page from scratch from the very beginning and then throw in various elements that you might see on web pages like text, links, lists, images and various other tags. Next we'll take a look at CSS, and CSS is more to do with the visual aspect of web pages. So we'll have a quick look at that, throw some CSS into our documents and see how it all links together. And then finally we'll take a brief look at JavaScript as well. Now JavaScript is the interactivity of a web page, and we're not going to dive too deeply into that, but I want to show you how it can be utilized with HTML. So that's about it to this introduction. I hope you're going to join me on this course. You're going to go from a HTML 0 well on your way to being a HTML ninja, and I'll see you guys in the next lesson. If you have any comments, questions, let me know below. Otherwise, subscribe to these videos and I'll see you guys in the next video.
Very good. So now we'll watch video. So how is the audio for you guys? Hold on, let me just make sure that everyone's able to get. So someone said the refresh is slow. Are you able to follow along? Is everyone able to follow along and understand what he's saying? Okay, very good. Okay, so now, yeah, the video is a little bit choppy. Luckily, a lot of it is text, so it's not like he's playing a lot of fast moving stuff. So, okay, we'll watch the second video.
Yo people, I'm Sean from the Net Ninja and this is HTML Basics Lesson 2, What is HTML? Now, before we start, I'm going to say this much. This ain't going to be a big history lesson on the derivation of HTML. If you want to learn that, you're more than welcome to go and scour the internet for plenty of articles out there. In fact, what I'm going to do is pop a link to one of those articles in this video description so you can click that and read to your heart's content. But me, I'm just going to give you a brief overview, like a bird's eye view of what HTML is and how it works with other web technologies. And then we're just going to dive in and create a website from start to finish. Alright, so first things first, what does HTML stand for? And it stands for Hypertext Markup Language. Now, this isn't that important to be honest, but I thought I'd mention it anyway. It's not a programming language, it's a markup language. And the difference is that a programming language contains often some kind of business logic. So say for example, I do something on a website, the website says, okay, the user's done this, it reacts and it shows me certain content. That would be a programming language or a scripting language that handles that kind of functionality. A markup language like HTML is just a way of presenting content in a structured and logical way to a user, and we do this using something called HTML tags, and I'll talk about that later on. Just remember for now, it's a markup language. Okay, so HTML is what I call one of three awesome technologies, and together with CSS and JavaScript, you can create some top looking websites. All right, so they're the three kind of core technologies you want to know to create some good looking websites. So HTML, like we've said, is the structure of a web page. CSS is more to do with the design kind of aesthetics of the web page. If I want to change the web page color, or if I want to change the font size of the title, or the font weight, or the font family, if I want to move things around and position them differently on the website, then I'm going to do that through CSS, which by the way stands for Cascading Style Sheets. And I'm going to do a course on CSS in the future. The third one is JavaScript, and this is more like the interactivity or the website's brain. So like I said before, if I go on a website and I click something, and say for example a pop-up comes up and says you want to join this mailing list, that pop-up is probably going to be controlled by JavaScript. And like with the CSS, I'll do a course on JavaScript in the future. This is all going to be about HTML, which is the structure of a web page. Now, I mentioned before that we control the structure of HTML with things called tags, and that's what you're seeing on this page here. There's loads of different kind of tags. This is just a few select examples. And basically all a web page is a series of tags, of different tags, on top of each other, underneath each other, and nested within each other. And we'll go into more detail about how this, how it's all structured later on. But just know for now that everything that you display pretty much to the user is going to be within a tag. Right, so some examples I've got here is a paragraph tag. And by the way, every tag normally opens like this: an open angle bracket, the tag name, closed angle bracket, then the content, and then you close the tag off with an open angle bracket, / the tag name, then a closed angle bracket. So the top one is a paragraph tag, and that's going to be great for things like articles. You're going to have the paragraph tag at the heart of all articles. So you've got the P for that, and then you put the paragraph text in between the tags. The next one is an anchor tag or an A tag, and that's used for links. So if I've got a navigation on a website and I've got loads of different links, then I use a combination of anchor tags to display links to the user. The third one is the H1 tag. That's to display headings, and they range from H1, they're the most important, right down to H5, I think, and they're the least important kind of headings. Then we've got a block quote. That's great for kind of displaying things like quotes. Then finally, the image tag, and you're going to notice something a little bit different about this. It's not got a closing bracket, and the reason is because it's a self-contained tag, and that means that everything within the image tag is within the angle brackets. That's all we need. All the information is there to display the image to the user. And I'm going to go in more detail about the image tag later on. In fact, there will be a video, no doubt, devoted to the image tag. So for now, what you want to remember is that everything pretty much in HTML documents is controlled or structured via these things called tags. And in fact, what we'll do now is take a quick look at an example of a web page. Alright, so here we are on the netninja.co.uk homepage, and as you can see in the top left here, we've got a logo. That's a H1. We've got some links here for the navigation. We've got the title. That's a H2, I think. Then we've got some images here, a link here, and all this is controlled by different HTML tags. And if I just right-click this screen and inspect element, this is going to bring open Google Development Tools. I'll just slide that over here. And you can see this whole HTML document here is just a series of different tags, and they're on top of one and each other. They're nested within each other, and if we drill right down, you can see at the heart of it all, we've got these basic tags like the H1 tag for the logo, like I said, and A tag that actually links to the home page. That's within the logo itself. We've got some H2 tags there, some list tags, that's for displaying list items, and we'll go through all this later. I mean, you're not going to recognize most of these tags. I'm just giving you a brief overview of how it's structured. So yeah, that's pretty much it. So what we'll do in this course is we're going to go through a lot of the more popular tags, certainly enough tags for you to kind of start making your own websites. But before we do that, I'm going to go through the syntax of HTML and how you kind of start a HTML document. So we'll do that in the next movie. I'll see you guys then.
Okay, very good. Okay, so we'll go ahead and stop there today. We're over time by about 5 minutes. That's okay. By actually about almost 10 minutes. Apologize for that. The quiz took a little bit long. So next time, remember the quiz is 15 minutes long. It'll always be around 15 minutes long, and it's in the beginning. So if you have not taken the quiz, please, let me just go ahead and make sure that everyone takes the quiz. Very important. If you have not taken the quiz, please take the quiz. Let me just quickly put the quiz back up. So let me put it back up. Let me share my screen. So very important that you need to take the quiz and then also sign in to get a copy of today's slides. So hopefully you can see my screen. Sign in to get a copy of the slides by scanning that QR code. So if you have not signed in, go ahead and sign in. And the link to sign in is also in the chat. I'll put it in the chat once again. And then also to take the quiz, I'll put that link in the chat really quickly. Because not everyone got the link in the very beginning. So let me put that link in the chat. Just a minute. Okay, so the link for the sign in is in the chat now. And then once you sign in, make sure you take the quiz. Here's the QR code for the quiz. So do the best on the quiz. It's not pass fail. We already went over the answers. If you missed that, it's just to give everyone an idea of what where you're at, so we know what to focus on time-wise. So, okay, here's the link to the quiz. I put that in the chat also. All right, we'll wrap up there for tonight. We'll see you guys next week. Have a good night.